So this part of chapter 8 is talking about solving quadratics. And we talked quickly, I tried to get it in your heads before we do any graphing, that a quadratic is really a parabola that opens up or opens down. And when you're solving for the x value, what you're doing is you are putting the quadratic function, which is normally in the form of y equals ax squared plus bx plus c, you're setting the y value equal to 0. And when you are putting 0 in for y to solve for x, what you're really trying to do is find the x-intercept. So in this case, you're trying to find where the parabolas would cross the x-axis. We're not graphing yet, so you don't have to worry about what it looks like graphically. That's going to be next week's lessons. But understanding that when you solve for x when y is 0 helps you to get ready for that graphing part. So the first type of question is the question where the quadratic has been factored already, and you have your two parentheses, and it's already set equal to 0. When you have something like this, it's pretty straightforward. You're just going to find out, using the zero product rule, if this parentheses multiplied by the next one gave you the value of 0, what could x equal? When we said that in order to solve, you set each parentheses individually equal to 0, as if it was an equation, to solve for 0. Some of them are pretty easy. It's an easy -4, and you could even see it at times. And you would set the other parentheses equal to 0, and you would solve by regular equation. And you could check your work by plugging each of these independently to make sure it works. If x was -4, -4 plus 4 is 0, and -4 minus 3 is -7, and 0 times -7 is 0. So you know that this one works. 3 plus 4 is 7, and 3 minus 3 is 0, and 0 times 7 is 0. So you know that that works, and your answers are x equals -4 and x equals 3. You could say your first x is -4 and your second x is 3, or you could just say x equals -4 and 3. Any of those methods of saying what x is equal to is absolutely fine. This next question is asking you to solve the quadratic equation, so we know it's quadratic because it's power of 2, by factoring. Well, in order to solve by factoring, you take your quadratic trinomial and you ask yourself, going back to chapter 7, how do I unfoil? Now, this is a simple one because a is 1, correct? Mm-hmm. So I can quickly, if I've become a little bit of an expert at this, I know that this is really 2 parentheses, and this is my first term, which must have been x and x. This is the last term. That means that they multiply to -8, and the outer and inner multiply or add, the outer term plus the inner term add up to 2. So what multiplies to -8 multiplies to -8 and adds to +2.
2 and -2.
What multiplies?
4 and -2.
4, +4, and -2. And again, we can do this because a is 1. If you had a coefficient that was 2 or 3 or 4 or 5, you would have to do the ACB method, right? So now I just take each parentheses and I say, cool, I'm going to set x plus 4 equal to 0. Now these are simple ones. So if you want to go straight into saying, oh, x is equal to -4 and x is equal to +2, that's fine. Only works when there's no a bigger than 1. But the actual method is setting it equal to 0 and solving. X minus 2 is equal to 0 and solving. And that's where we get these methods, these answers, solutions. Plug it in to try it. Negative 4 squared is 16. 2 times negative 4 is negative 8. 16 minus 8 is 8 minus another 8 is 0, so that one works. Try the 2. 2 squared is 4. 2 times 4 is 8. 2 times 2 is 4. 2 squared is 4. 2 times 2 is 4. 4 plus 4 is 8. Minus 8 is 0, so you know that these are correct. Awesome. Okay. There is definitely a question like number 2 and 3 for sure. Pretty much every question that's on this study guide is similar to that of the test, except for number 1. You don't have one that's already factored out. Every single one of the 11 questions on the summative require that you factor them first. So if you could do this study guide, you are absolutely 100% set for the test. Cool. All right, now for number 3, they want us to do factoring as well. And even though I did not do the ACB method above, because it was a simple A is equal to 1, like we said, you can always use the ACB method. But even in this one, you have to use the ACB method. So when you go to factor, remember your steps to factoring. 1, is it in standard form? In this case, it is. 2, is there a GCF? Can I factor anything out of those 3 terms? No. Step 3, is it a special case? No, it's not. The square root of 3 is not a perfect square, right? 3 is not a perfect square, so you can go straight to the ACB method. Okay, so this is the factoring steps. Remember that the special case is when it's squared. Special case would be something like 4x squared minus 16, or 4x squared minus 32x plus 16, where you can take the square root of those. Okay. Okay, so let's go through this question. I'm going to complete the ACB method, so I need to first factor what multiplies, A is 3, C is 15, what multiplies to positive 45 and adds to negative 14.
5 and 9.
9 and 5, good. 5 and 9, yeah. Multiply to a positive, so that means they both are the same sign, add to a negative. And negative 9 and negative 5 expand out the middle term with the x, so negative 9x minus 5x. Rewrite the plus 15 and the 3x squared. Now we have 4 terms, which means we can group it, and factor. What can I factor out of 3x squared minus 9x? 3x. What's left?
X minus 3.
Fantastic. When I have a leading coefficient that's negative, such as a negative 5, what do I have to remember? You have to take out the negative, right? So what's the GCF of this?
5. Negative 5.
Negative 5. Because remember, the leading coefficient is negative, so you got to factor out the negative. And what's left inside? X minus 3, right? Because it was a positive and you divided it by a negative. And then you've got what we call the little twin guys, x minus 3. And you're left with 3x minus 5. But we're not done yet because we factored, but they want us to solve. What's the next step?
Plug both situations into 0.
Fantastic. Step 1. In this case, you're not going to be able to just say that x is positive 5, because if you say 3x minus 5 has to equal 0, and you go ahead and do your solving, you add 5, you get 3x equals 5. Then what you do is you divide by 3.
So you actually do that in your calculator.
And you're not going to do the division. You're just going to leave it as a fraction, okay? So the only time you would divide it out and get a decimal is if they gave you a problem with decimals in it, or if they said round to a tenth or something like that.
Okay.
But in algebra, we always leave fractions as fractions, even if they are improper. So you're just going to leave it as 5/3. Don't even put it as 1 2/3. So that's the first one. The next guy that I got to set equal to 0 is x minus 3. So you say if x minus 3 is equal to 0, pretty easy. That one's just x equals 3 because you added 3. So your two solutions are that x is equal to 5/3 and to 3. And that's your answer. And I'm going to show you how to check. Remember, we talked about evaluating, finding the value of, and we said whenever you have variables that you're plugging in values for, rewrite the problem with parentheses first. So that means you would say 3 times x squared minus 14 times x plus 15 has to equal 0. And then your very first thing you're going to plug in is 5/3. When you plug in 5/3 here and here, you then follow order of operations. So 5/3 squared is 5/3 times 5/3, which is 25/9. That's being multiplied by 3 minus, now you've got to do 14 times 5/3. Well, 14 times 5 is 70. Yeah, I just rewrote the negative there. 70/3. And then plus 15 equals 0. Now, remember, you guys have calculators at this point, so this is going to help you quite a bit.
Yeah.
This is insane.
When you do 3 times 25 nines, you're going to get 25/3 minus 70/3 plus 15. And when you plug that into your calculator, you're going to get 0 equals 0. So you know 5/3 is correct. Now we're going to plug in 3, just to make sure it's correct. This one's a little bit easier because it's no fractions. 3 squared is 9. 3 times 9 is 27. 14, negative 14 times 3 is negative 70. I mean, not 70. That was the last one. 30 plus 42. And then plus 15. Well, 27 minus 42 is negative 15. Plus 15 is equal to 0. So you know that it's correct also, and that means you got the right answer. We know that every time we see a word problem, we get really nervous because there's words and math and all that stuff. But you should already know that you are simply working with quadratics at this point. If we read the question first, it says, the height of an arrow that is shot upward with an initial velocity of 40 meters per second and can be modeled by, okay, so they're giving me the equation. They're not even telling me that I have to know how to write the equation. I know the equation. If I'm throwing an arrow upwards,
How do you throw an arrow?
you might be tossing it with, like, you're not maybe throwing it, but you're actually using a bow and arrow. So the arrow is actually going up with the initial velocity of 40, blah, blah, blah. H is the height in meters, and T is the time in seconds. Find the time it takes for the arrow to reach the ground. Guys, what is the height of the arrow when it's on the ground?
0.
Height is equal to 0. You have your equation. Height equals 40t minus 5t squared. They're asking you, what is the time, what is t equal to when h is 0? So all you have to do is go, oh, I'm going to plug 0 in for h, and I'm going to solve. At this point, you remember that when you're solving a quadratic, you should always put it in standard form if you're going to factor. So I am going to add 5t to both sides, right? So that I don't have a negative a. So that's going to give me 5t squared. Then I'm going to minus 40t. So minus 40t. And on the right-hand side, I'm going to get equals 0, correct? basically you just flipped everybody's order so that the A was not negative. I'm going to show you both ways of doing this if you wanted to not even rewrite it. Then I have my steps. Factor. Well, is it in standard form now?
Yes.
Yes. Is there a GCF?
Yeah.
Yes, there is. 5t. What's left? T minus 8 equals 0. Now I have parts that multiply to give me 0. So what's the next step? Set each parentheses or every part equal to 0. And then I'm going to do t minus 8 is equal to 0. And then I just solve. Well, if 5t equals 0, t is obviously 0. And then if t minus 8 is equal to 0, I add 8. And I get t is equal to 8. Now, please remember this is a real world application, which means you got to look at real world time, real actual common sense. If I know that the arrow is up in the air, even though factorably, mathematically, in 0 seconds it's going to be on the ground, that's basically implying that you never shot it. So it never went anywhere. So the answer is going to be the reasonable one, which is 8 seconds. In 8 seconds, after it is launched, it will hit the ground. That means that the projectile trajectory went launched, went up, and then it hit the ground in 8 seconds. So when you're... There are also, beyond factoring solving, questions where you need to solve using square roots. And it'll tell you to solve by square roots, so it's not going to ask you, oh, you just have to know how to do it. You have to go through the method of solving by square roots. So for this first one, when I'm asking to solve by square roots, I'm trying to find the value of x. So I'm going to take the square root, and you're right. When you take the square root of a negative, there's no solution. So in this case, it's no solution. Excellent. All right, let's look at the next one. The next one, again, you're solving using square. When you're solving using square roots, what you need to do is you need to try to set it up like a regular equation so you can just solve by square rooting. So even though it's already set equal to 0, as it should be, when solving using square roots, in other words, when there's no bx, remember, ax squared plus bx plus c, when there's no bx and there's just an ax squared plus c, basically, all you need to do is discover how to set it equal to, or isolate the variable, I'm sorry. You would get 64x squared is equal to 121. What's the next step that I'm supposed to do?
Square root.
No, undo what's being done in the reverse order. What's the first thing I have to undo before? Order of operations says you do exponents before multiplying and dividing. So to undo it, you do multiplying and dividing before you do exponents. So you're supposed to divide by 64, and you get x squared is equal to, and when you do 121
1.89.
divided by 64, thank you, you get 1.89. And what am I supposed to do now? How do I unsquare?
Oh, right.
Square root. And how many answers do I get for square roots when it's a positive inside? 2. Positive and negative, and then you take the square root of 189 and you get about 1.375. 1.38. One of those. I'll tell you what to round to, but if I left it like that, it would be fine. All right. Now the next one, again, it's asking you to solve using the square roots. And look, it says round to the nearest tenth. So the first thing I do if I'm solving with square roots, all I'm trying to do is isolate x, undo what's being done. You're going to add 10 to both sides. Very good. you're going to get 2x squared is equal to 74. What do I undo now? You divide by 2, and you get x squared is equal to 37, I believe.
Yes.
And now, how do I unsquare? Take the square root, and you get x is equal to, don't forget plus or minus, don't forget plus or minus, don't forget plus or minus. The square root of 37 is 6.0827. They want me to round to the nearest tenth, so I'm going to look at the 0, which is the tenths place, and the 8 tells me to go up. So this is x equals positive and negative 6.1, and that's my answer. Remember, quadratics almost always have two solutions. And so in this case, it means the solutions, because there's no bx, it means that it's crossing at 0, and you're trying to find the number 8. Ooh, I was just looking at a question like this on the test, as a matter of fact. This here is telling you that you have two sets of 2x plus 1s. This is actually probably easier than anything else. What you're going to do is you're not going to expand out the two sets of 2x plus 1s. What you're going to do is you're going to look at it and go, oh man, I am squaring this. So I need to unsquare. Do you see how this is a little different than the previous one? I want you guys to look at if you look at this here right now, and then you go back to the previous one, look at the difference between the two questions. This question, number 8, the whole parentheses is squared, as opposed to here that only the x is squared, right? So with only the x squared, you're trying to get x by itself, and that's why you have to add 10, divide by 2, and then take the square root. With this one, however, you need to take that squared parentheses and unsquare the whole entire thing. And what happens is that you're left with just 2x plus 1, because when you unsquare something that's squared, you're undoing it. When you take the square root of something that's squared, you're literally unsquaring it. That's why that left part is equal to 2x plus 1. And then the square root of 25 is positive and negative 5.
You read it like that?
It's plus and it's minus 5. Now, what this is telling me is that I'm really 2x plus 1 equals positive 5, or 2x plus 1 equals negative 5.
You forgot the 1 there.
Oh, thank you. 2x plus 1. Thank you. Okay? So, we unsquared. Let's go through that again before we continue solving this. Before we continue, we unsquare this. You get 2x plus 1 by itself is equal to the positive and negative of 5. Then, what this is inferring is that you have 2x plus 1 equal to 5 and 2x plus 1 equal to negative 5. Now you're going to solve like normal. Subtract 1. 2x is equal to 4. Divide by 2. My first answer is that x is 2. Then I do the same thing on this one. 2x is equal to negative 6. I am going to divide by 2, and I get that the second x is equal to negative 3. So these are my answers. Let's check the work, and I'm going to show you again how to check your work. You're going to check your work by making the 2x plus 1 squared 2 times x plus 1 and squared equal to 25. We want to see if this works. Our answers were 2 and negative 3. So let's start with 2 first. If we put 2 in here, 2 times 2 is 4. 4 plus 1 is 5. 5 squared is 25. So yes, that one's correct. Then I plug in the negative 3. 2 times negative 3 is negative 6. Negative 6 plus 1 is negative 5, and negative 5 squared is positive 25. So I know that not only is the 2 correct, but the negative 3 is also correct. There was a question like this on the homework assignment.
It was on the
So, yeah, it was the example. It says a rectangle, so I always draw a rectangle, is twice as long as it is wide. Well, if this is the width and this is the length and it's twice as long as it is wide, that means that the length is really 2W. The area of the rectangle is 32 square feet. Find the length and the width. Well, I know that the length is 2 times the width. So look at how I wrote that again. Length is 2 times the width. The area, and they give me the area formula, length times width. The area of the whole thing is 32 square feet. That means that the length times the width gave you 32. Well, 2W times W is 2W squared is equal to 32. What do I undo first? Divide by 2. And I get that W squared is equal to 16. What do I do now? What do I do now? Take the square root. Theoretically, it's supposed to be positive and negative 4, but I'm not going to have, in a real world, negative length, so I'm going to just throw that one out. So I know that the width is 4, but they're asking me for the length and the width. If the width is 4, what's the length? 8, because it's twice the width. So I know the length is 2 times W, and W is 4, so 2 times 4 is 8 feet, and the width is 4 feet. Now we get to the fun part where they're asking you to solve using the quadratic formula. Now, on the test, there are only 2 questions that ask you for solving using the quadratic formula, but it's important that you remember what the quadratic formula is. All right, to use the quadratic formula, I have to have my expression or my function written as ax squared plus bx plus c equals 0. So what I need to do is subtract the 8x so that I get 0 is equal to x squared minus 8x, because it has to be in standard form, minus 9. A is 1, b is negative 8, and c is negative 9. The quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. And then all I'm going to do is plug a, b, and c. So I know that a is 1. Okay, that makes it easy. So this becomes 1. And this becomes 1. I see that b is negative 8. So when I go to put b in here, it's the negative of negative 8. B here. And then the last one is that c is negative 9. So c is negative 9.
We told them not to.
So negative of a negative is a positive. That's going to leave me with 8 plus or minus the square root of negative 8 squared is 64. Negative 4 times 1 is negative 4. Times negative 9 is positive 36 all over 2. That's going to give me 8 plus or minus the square root of 100 and then divided by 2, which is going to be 8. And that's going to be 8 plus or minus 10, because the square root of 100 is 10, over 2. And remember what this represents. This here represents 8 plus 10 divided by 2 and 8 minus 10 divided by 2. So that when you do 8 plus 10 is 18 divided by 2 is 9. That's one answer. and 8 minus 2 is negative 2, divided by 2 is negative 1. So my answers are 9 and negative 1. Using the quadratic formula again, the formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So when I look at this, I know a is 3, b is negative 6, and c is equal to 1. So when I go to punch in or to put them in, I'm going to say that b is negative 6. So when I put negative 6 in here, that's going to be kind of positive. I'm going to change this b also to negative 6, but it's negative 6 squared. Then I'm going to change the a to 3, so I'm multiplying by 3, and c is just 1. The a at the bottom is also equal to 3, so it's 2 times 3. So when you plugged in your values, this is what you should have gotten. From here, I am going to take the math problem. I am going to see that the negative of negative 6 is a positive 6. Bless you. Plus or minus the square root of 6. Negative 6 squared is 36. Negative 4 times 3 times 1 is negative 12. All over 2 times 3 is 6. That is going to become 6 plus or minus the square root of 24 over 6, which is then, I have to actually calculate the square root of 24 to get a decimal. So you type in the square root of 24 on your calculator, and you get about 4.898, which is really 4.9. So then you're going to do 6 plus or minus the square root of 4.9 and then over 6. Remember that the plus or minus, what this is representing, is 6 plus 4.9 and then 6 minus 4.9. I'm sorry, what mistake did I make?
Your son's standing outside.
So in this case, it's not I already took the square root. So it's 6 plus the 4.9 and then divided by 6. That's what this part says.
Why is it negative?
And then the other one is 6 minus 4.9 over 6, correct? So I do 6 plus 4.9, and what do I get?
10.9.
10.9 divided by 6 gives me what? 1.82, rounded to the nearest hundredth. And 6.6 minus 4.9 is what? 1.1 divided by 6, 0.18. These are the two values of x. So if to discriminate means to judge unfairly, discriminant similarly means to judge. But in the case of mathematics, it's judging how many solutions you have. Now, what part of my quadratic equation, if I look at the entire quadratic formula, which part is the part that would make it so I would have no solution whatsoever?
Square root.
The square root, right? If the inside was negative, it would say I have no solution. If the inside was positive, it means that when I take the square root of any positive number, I have two solutions. If the inside was equal to 0, you can only have one square root of 0, which is 0. And because you can only have one square root, it means you only have one solution. That's the reason to why the discriminant is the inside of the square root, which is b squared minus 4ac. So if you are asked not what are the solutions, but how many solutions do you have, you don't need to use the whole quadratic formula. All you need to use is the discriminant, the guy on the inside of the square root. But you do the same thing in that you're substituting a, b, and c properly. B is 9. So 9 squared minus 4 times A, which is 8, times C, which is 5, gives you 81 minus, well, 32 times 5 is 160. And 81 minus 160 is going to give you a negative number, isn't it?
Yeah.
That's right. That means the inside of the square root is negative, and you can't do that. So that means you have no solution. If, and make sure that you're able to do all of them, not just the ones that are no solution. If you did all the work and you got a positive number, that means you have 2 solutions. Again, you're not using the discriminant to find what the solutions are. You're looking at it to find how many solutions I would have if I actually solved it all the way. So let's finish real quick this little chart. So if the b squared minus 4ac is positive, you have 2 solutions. If it's negative, you have no solutions. And if it's 0, you have 1 solution.
Which is 0.
No, it's not necessarily 0. So if you had, for example, the quadratic formula, and you had x equals, I'm just going to say like you did the work and it's negative 5 plus or minus 0 over 10. When you go to do the work, your answer is not 0. The discriminant is 0. You're right. The discriminant is 0, but that means you have 1 solution. The reason you have 1 solution is because you're going to do the math, and you're going to do negative 5 plus the square root of 0 is just 0 divided by 10.
Both times it's going to be
Exactly. And then you're going to do negative 5 minus 0.
Which is also negative 5.
Exactly. Divided by 10. And just exactly like you said, you're going to get the same thing, negative 5 tenths, with just 1 solution. So this is just a way of figuring out how many solutions I'm going to get. Just because your discriminant is equal to 0, it doesn't mean that your answer is equal to 0. It doesn't mean that your x is equal to 0. It means that you have 1 solution. So that's the reason to why we use this little thing to help us.